Hi everyone. In this video, I'm going to be doing a projectile motion problem from the June 2023 Physics Regents. The problem says, a projectile is launched from ground level with an initial vertical speed of 26 meters per second upward and an initial horizontal speed of 15 meters per second. Neglect friction. The first thing I want to do is annotate using cubes. So I'm going to start by circling my numbers and units. Normally I would underline the unknown, but I'm not really at that part of the question yet, so I'm just going to box some keywords. I did not choose to box projectile. This word just means something that's being launched into the air, so I didn't think it was super important. Instead, I boxed launched because that reminds me that this is a freefall problem, and it reminds me that I should be thinking about the acceleration due to gravity. I also boxed initial vertical speed because that tells me something about the 26 meters per second. I boxed upward because that means the 26 should be positive. And I boxed initial horizontal speed because that shows me what 15 meters per second is supposed to be. There's a lot of information here, so I'm going to draw a picture. I have some object starting on ground level, and it's going to travel in this arc and come back down. I started by labeling my vertical and horizontal velocities at my starting point. So the initial vertical speed is 26 meters per second upward, so I drew that with an arrow. At this point, the ball is traveling, or the projectile is traveling at 26 meters per second up. But it's also, at the same time, traveling 15 meters per second to the right, or horizontally. Now, I know that at the top of the path, the velocity is supposed to be 0, but that's just the vertical velocity. So I wrote 0 meters per second in pink, which is what I'm using for my vertical motion. But I also wrote 15 meters per second in blue with an arrow pointing to the right because the velocity in the horizontal direction is going to be 15 this whole time. And so even at the end, it's still going 15 meters per second to the right. Even though they didn't tell me how fast it's going when it lands, I also know that it's going to be going negative 26 meters per second in the vertical direction. And this is a rule that you can always count on. Whatever your vertical speed was when you launched the object, that's going to be the same amount of speed, or the same vertical speed, just in the negative direction when it lands. So 26 meters per second going up, it's going to turn into negative 26 meters per second going down. So that kind of sums up all the information I have for this problem. Let's take a look at question 56 and 57. It says, calculate the total time the projectile is in the air before the projectile returns to the level ground. We're looking for total time, so that's my unknown. That's what I'm going to underline. The thing that I thought was most important was this phrase, returns to the level ground. And I thought that was important because I'm not just looking at the time it takes to get to the maximum height, or how long it takes to come back down. I'm looking at this entire thing. So sometimes when we do problems like this, we might be looking for the maximum height, or how long does it take to reach the maximum height. And then you would use this as your initial velocity, and this as your final velocity. So because they told me that I needed to return to level ground, I want to make sure I'm actually looking at the entire path. So I wrote t equals question mark because I'm looking for the total time, and I wrote vi equals 26 meters per second. I chose the vertical velocity because I'm going to have just more information in the vertical direction. I have vi is 26 meters per second. I also know vf is negative 26 meters per second. And that's again because it says returns to the level ground. So I don't want to write 0 meters per second here because I would only really be doing half of the problem. I also know my acceleration is negative 9.81 meters per second squared, and that's just because this is a freefall problem. Additionally, I'm working in the vertical direction, so this might change when we get to the horizontal problem. I'm picking an equation and solving, so I picked VF equals VI plus AT. My equation has to have time in it, so that's good, and it should have mostly these other variables. I'm allowed to have extras over here, but if I have something random in this equation that I don't have listed, I'm going to run into a problem. So this is a perfect match. I have VI, VF, and A all in my equation. At this point, I'm ready to start plugging in my numbers. Negative 26 equals 26 plus negative 9.81 times t. I subtracted 26 from both sides. Be careful here because negative 26 minus 26 is not 0, although it may make you think of 0 when you look at it. The 26 minus 26 cancels out, and this turns into negative 52 equals negative 9.81 t. My next step is to divide both sides by negative 9.81. And that leaves me with my answer. 5.3 seconds is time. Let's move on to question 58. Determine the total horizontal distance the projectile travels before the projectile returns to the ground. I underline distance. I'm solving for d. But I also put a box around horizontal because I'm solving for the horizontal distance, which means all of my information should be related to the horizontal motion of this ball. So I wrote d equals question mark because that's what I'm looking for. And then I wrote a equals 0 meters per second squared. Something that you need to know is that there's no horizontal acceleration in a free fall problem. Anytime an object is moving through the air, whether it's just going straight up and down, or if it is moving to the right or to the left, there's never any horizontal acceleration. And that's because there's no horizontal force. When something's moving through the air, gravity is the only force acting on it. So gravity is pulling down, but there's nothing pulling or pushing left to right. So my acceleration in the horizontal direction is 0 meters per second squared. And if I take a look at my diagram, I can see my horizontal velocity is 15 meters per second, initially and at the end. So that means I can write VI is 15 meters per second. VF is also 15 meters per second. And time is 5.3 seconds. I took this from question 56 and 57. So I already calculated time. This carries over into this problem. To pick an equation, there's more than one that we could use because we have a lot of variables, but I'm going to pick this equation. D equals VIT plus 1/2 AT squared. And the reason I picked it is because I'm looking for distance or displacement, and I have all these other variables. I even have VF, which I'm just going to not use, which is totally fine. Before I get started, I'm going to cross out this whole section, and that's because acceleration is 0. So no matter, I can plug everything in if I want to, but it's just going to take a little bit of extra time. So I know that if A is 0, this whole term is going to turn into 0. So I can just cross that out. And the formula that I'm really working with now is D equals VIT. I'm just going to plug in my numbers, 15 for VI and 5.3 for time. And when I multiply, I get distance equals 79.5 meters.